Okay, so absolute value inequalities. Some of the rules are the same for inequalities as equations, and some of them are different. So if you recall, when we were doing equations, we would have the absolute value of something equal to 7, let's say. And then what could x have been to make this true? Positive or negative 7 would have been true here, right? You got two different answers, right? Because the absolute value of positive 7 is 7 and the absolute value of negative 7 is 7. So I got two answers here. So for the inequalities, a lot of them are going to have, well, I might get multiple answers again. Okay? Let's just take a basic one. What if I asked you the absolute value of x is less than 7? So first of all, I want you to think, are there numbers that have an absolute value that's less than 7? Sure there are. Give me an example of one. 6. Sure. 6 is one answer. There's lots more though, aren't there? 0. 0, 1, 2, 3, 4, 5. Even decimals, right? 4.5. 2.5. So basically anything between 0 and how high can I go? Well, could I include 7? If I plugged 7 back in, would that be a true statement? No, because the absolute value of 7 is 7, but 7's not less than 7. If I had the or equal to bar, I could do it, but I don't here. So basically, I can go up to 7, as close as I can get, but I can't actually include 7. So I can have anything less than 7, but there's another part to it. Are there any other numbers between 0 and 7 that could go in and make this answer? What?
6.9.
True.
What if it's like less than negative 1 is still less?
Oh. What if we went into negative land? Negative 1. Does negative 1 work? Yes, because the absolute value of negative 1 is 1, and 1 is still less than 7. Can I plug in any negative number that I want? No. If I tried negative 10, for example, if you plug in negative 10, it's not true anymore. So how low can I go?
Negative 6.
Right, I could go just like on the positive end, I could get as close to 7 as possible, but I can't actually touch it. So I could go to like 6.999999999 if I wanted. Same thing in negative land, as long as I don't actually get to negative 7. Okay? Does that make sense? So this answer is a range of numbers. It's anything. Here's how we end up writing it, but we'll kind of break down how to do this normally. I can have anything that's bigger than negative 7, but it also has to be less than positive 7 at the same time. Does that make sense? So anything, that's my answer right there. So here I had just x equals either one number or two numbers. Usually it's two numbers, right? Here I'm going to have a range of numbers sometimes. Or, so remember the and or inequalities? What type is this? And. So some of your answers are going to come out as ands and some of them are going to come out as ors. And it's up to you to figure out which one it is. I know. So these are a little bit more complicated than equations because you have to stop and think about your answer and figure it out. But I'm going to give you all the steps. So I'll give you all the steps and we'll see how to turn it into correct answers. Okay, you ready? I'll take your silence as a yes. Yes, we're ready. We can't wait. We're so excited. And actually, before we get into that, let's talk. There are ones that have no solution. How could I have no solution with an inequality here? If this number is negative?
Yeah.
So it depends. I can't have an absolute value that's less than a negative number, right? How could I? Like if I said the absolute value of what is less than negative 2. That's impossible. There are no absolute values that are negative at all. So how could I get one that's less than negative 2? Right? You with me? So that has no solution. However, let me ask you this question. What if I had it the other way? Who has an absolute value that's greater than negative 2? 2 does. That's 3. How about everybody? Isn't everybody's absolute value is either 0 or some positive number, right? Right? You can't get an absolute value that's negative. You can only get out absolute values that are positive or 0. So no matter what I plug in for x, isn't everybody's absolute value going to be greater than negative 2? So in this case, this doesn't have no solution. It has all the solutions, or all real numbers. So you do have these special cases that come up sometimes. Again, most of the time we have an answer, we find it like normal, but occasionally you could have no solution. So you cannot have an absolute value that's less than a negative. Everybody's absolute value will be greater than a negative, though. Everybody's. Does that kind of make sense? I hope. Okay. All right. So those are the things that we want to keep in the back of our mind, because if we come across them, we get to stop doing extra work. All right. So I'm going to give you an example problem, and we're going to walk through it as we write down the steps. So I'm just thinking. Let's start with a really basic one, and then we'll try some other ones. All right, how about this? How about we do the absolute value of x plus 3 is less than 10. Okay, so let's write some steps over here. How to solve. Your step 1 is going to be the same as it's always been. You always want to get the absolute value alone. And I'm going to add a special star right here. Yes. So step 1 is already done for us in our example. But I'm going to add a special star because, remember, we are dealing with inequalities. So if in doing step 1, I had to multiply or divide either side by a negative, what happens in inequalities when you multiply or divide both sides by a negative? What'd you say? If I'm dealing with anything that's an inequality and I had to multiply both sides by a negative number, what happens?
Change the sign.
The sign flips over. Yeah, so that's any time you're dealing with inequalities, whether they're absolute value inequalities, it doesn't matter. So I just want you to not forget about that. If you multiply or divide both sides by a negative, flip inequality over. I'm sorry, it's a little hard to. Whoa. Okay. All right. I don't have to do that in this first example, but I'm sure we'll have one at some point where we need to. So just don't forget that needs to be done. So great, step 1 is already done for me. Now, just like for equations, I am going to rewrite it twice. But there's another little difference here. So step 2, we are going to rewrite twice. You don't know the final answer yet. You might know one part of one piece of an answer. Rewrite twice. Once, again, just exactly as you see it. Exactly as is, no bars. Second time, no bars. And when it's an equality, we just put negative 10 instead, right? There's two things you have to do for this. When you rewrite it the second time, not only is it going to be a negative 10, but you also have to flip that symbol. And that's how we kind of, if you remember back up here, that's how we're going to end up setting up this range for ourselves. Okay? So, second time, no bars, flip inequality symbol. And make the number negative. If the number's already negative, now it would go positive, right? Okay, so step 1 is already done. Step 2, I need to rewrite this twice. So, once, I'm going to write it just like I see it, no bars. X plus 3 less than 10. The second time, however, please watch and make sure that you are doing it the right way. You want to write it as x plus 3, but now that symbol flips over, and now that's negative 10. You have to remember to do both of those parts. So important. And now I'm ready for the third step. I'm going to solve each one. Solve each. So that part's easy enough. Okay, minus 3. I get x is less than 7. So that's one part of my answer. That's only one part. And now, on the other side, minus 3, I get x is greater than negative 13. And unfortunately, you're not done here. Well, you're almost done. Good thing we have all these steps written down nice and neatly. There's only one more. It's okay. Well, the last step is to just decide if your answer is an and or an or. So, you got to look at your two answers that you have. I want numbers that are less than 7, and I want numbers that are greater than negative 13. Are there numbers that fit both of these at the same time?
No.
Yes, I have numbers that are less than 7 that are also greater than negative 13. Right?
Yes.
Yeah, there are numbers that fit both. So if there are numbers that fit both, that means that your answer is an and. If there are not answers that fit both, then your answer is an or. You with me? So let's write that down in words. So step 4, decide if.
That's the last step.
Yeah, pretty much. Well, kind of. Answers are and or. And write accordingly. So in this case, we decided that it was an and. So remember, you have two options for how you write and answers. I don't care which of the two you use. I have a preference, but I'm not going to mark you wrong. But you have to include the word and or. So if you just give me this on your answer line, I have to take some points off. Because you're not done. You didn't indicate if it was and or. So the two ways that you can write your answer, you could write it as x is less than 7 and x is greater than negative 13. That would be fine. But do you remember how to write and equations as that one unit? Sort of that one chunk? Do you remember? Well, let me refresh your memory. If you don't like it and you just want to do this every time, fine. But if it's multiple choice, they're probably not going to write it like this. So you need to be able to recognize. So how do you rewrite it? You take the smaller of the two numbers. Out of 7 and negative 13 smaller. So that one comes first. And then the Pac-Man always eats the X there. And then it doesn't eat the X for this one. And then you put the 7. So if you are writing it as an and sandwich, as I like to call it, the arrows will always go this way, as long as you put your smallest number there and your biggest number there.
If they knew how to write it that way, wouldn't that also help them determine whether it's an and or an or? Because if they couldn't write it like that, then it wouldn't be an and, it would be an or. I don't know if I'm confusing everyone, but.
Oh, you're saying, yeah. So so here's one mistake that a lot of kids make. They'll take an or and they try and force it into this. So they'll try and write something that like makes no sense. Like, for example, don't write this down, but say you had that makes no sense at all. Because look at what it's saying. This is saying that this is a number that's less than 8 that's also greater than 10.
Right.
That's not true, and that's impossible. So you can't ever give me an answer like that. So that would be an or.
Yeah, I don't know. I'm just looking at another possibility of helping them determine.
Yeah, whatever works.
Yeah.
Whatever works, guys. So, for ands, you can write it either way. I don't care. If it is multiple choice, you're more likely to see it written this way. So when you go to take that MCAS exam, it's probably going to be like this. Ors cannot be written this way. Ors, you only have this option, but you would have the word or there.
Because otherwise you have something like that that does not make sense. That was my point.
Yes.
But
Now, you may or may not be asked to graph the solution. So if you're asked to graph, you guys remember how to do it. You put dots at the negative 13 and at the 7. Would they be open or closed in this case? Open. And then for an and, most of the time we just shade in between. Okay. Try another? All right. How about... we'll stick with... Huh?
Or.
Yes, we'll try one that's an or. How about... X minus 4 minus 2 is greater than... Let's do 8 maybe. All right, so according to step 1...
To rewrite the equation.
Whoa, 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 whoa. Step 1, I have to
And absolute
get the absolute value alone. So in this case, the absolute value is not alone. So I would have to add 2 to both sides first. Add 2, add 2. Okay, that wasn't so bad. Now step 2 calls for me to rewrite this twice. Go ahead and rewrite it twice, but don't go any further than that. I just want to see if you know how to rewrite this the 2 times. One time it's going to be exactly like you see it, no bars. The second time, make sure that you are doing the things that you're supposed to do when you rewrite it the second time. Okay, so first time, you should have written x minus 4 is greater than 10. Just like I see it, just no bars. The second time, I'm going to write it as x minus 4, then what?
less than
Less than negative 10. Please look at your papers and make sure that you did both of those things. You flipped that symbol over and you made that negative. You have to do both. We're okay so far? All right. Now I solve each one. So add 4, add 4. X is greater than 14. That's not so bad. And now we're at the next crucial step. I have to stop and ask myself if this is going to be an and or an or. So I have to think to myself, are there numbers that are bigger than 14 that are also less than -6 at the same time? No, you cannot give me a number that fits both of them at the same time. There is no number that's greater than 14 that's also less than -6. So, since there are no answers that fit both at the same time, it has to be an or. So for this, you literally just get to write the word or in between and throw a box around it and you're done. If you were asked to, well, let's go ahead and graph it, why not? So if you're going to graph your solution, make sure you have a -6 on there, make sure you have a 14 on there. What kind of a dot would go at the 14? Open and shaded to the right. And on the -6, what kind of dot? Open, shade to the left. So if you are asked to graph your answer, there it is. Is that okay? All right. If you wanted to check an answer like this, you absolutely can. You're just going to pick any number that gets shaded over. So you could pick 15, you could pick 20, you could pick 1,000, you could pick -10, -99. But you could not pick any number in between these two because those are the ones that are not going to work. Is this okay? Does this make sense? So, as long as you follow these 4 steps in order, you should be fine. It is weird at the end kind of deciding, well, is this and or? But if you just think about it, you should be okay. All right, we ready to try some?
Yes.
Okay,